All right, so this is our third video. Before I move on to the next page, I completely forgot one other piece of information I need to include in this Venn diagram. And if you look at the numbers here, we had the 8, the 12, and the 16, and that added up to 36, but we had 38 total people. And that's because there were 2 people that were not cat or dog people at all. Well, that's actually what goes in this box, and it doesn't really matter where you put it. Most of the time we write it in the lower part of the box, but the area inside that box that's outside of the circles is basically the leftovers. So that's those 2 extra people. All right, let's move on to the next one because we'll see that exact same type of thing again in the next example here. So part 2, what is the relationship between advertising and sales? So a group of 500 moviegoers watched 10 minutes of movie previews prior to the start of the movie. For half of the moviegoers, the previews were not only previews, but they included ads for concessions like popcorn and soda. Whether or not the moviegoer purchased a snack from the concession stand was then recorded in the two-way table below. So it sounds to me like somebody's trying to figure out whether showing previews that had concessions in it made people want to go buy concessions or not. So you got 2 different things. People either purchased concessions or they didn't. And that's these 2 pieces right here. They either purchased concessions or they didn't. And what they did was they did a sample survey. And they, again, half of the people had no ads. That's this one. Half of the people saw ads. That's this one. And if there was 500 total people, half and half is 250 apiece. So according to the data that they collected, of the people who had no ads, 134 of them still purchased concessions even though they weren't shown anything. The other 116 didn't. Of the people who saw ads, 188 of them purchased concessions, but only 62 didn't. So in total, there was 322 people who purchased concessions and 178 that did not. And again, those totals have to add up to the total number of people, which was 500. Okay, I'm erasing all that stuff so we can dig into the problems now. So suppose we want to choose a moviegoer from the sample at random. Define the events. So event A is going to be people who saw ads during the preview. Event C is going to be people who purchased concessions. So we've got an event A and an event C. So people who saw ads, people who purchased concessions. So here is our Venn diagram to display the sample space of the chance process by completing the Venn diagram. It says below, but it's really to our right. So again, there are people who saw ads, and there are people who purchase concessions, and then there's going to be some kind of an overlap. So let's see if we can figure it out. There were people who saw ads, so we're in this category, and people who purchase concessions. So there's an overlap there. That's that one. That goes in the middle because that is both. That is both in A and in C. So we'll actually say that this is event A. I'll do that in a different color. This is event A, purchasing. Oh, nope, sorry. They have it labeled differently. A is the people who saw ads. That goes up here. All right. This is just horrible. There's my A. Okay. And then people who purchase concessions is event C. So we'll put a C over here. Okay, so there's 188 of them that did both. The people, the total amount of people who saw ads, but didn't purchase concessions was 62. So that goes out here. Because if you add up the 62 and the 188 that's inside that circle, that adds up to the 250 here. And then the people who purchase concessions Well, let's see, there was 188 of them that saw ads, but there was 134 that didn't see ads. So there's going to be 134 out here, because then if you add up this plus the 188 across, you get there's a total of 322 people that purchased concessions, which is the sum of those two. Oops. Okay, there we go. All right, so we've labeled. Now we're going to interpret the 4 distinct regions of the Venn diagram. And there are 4. Because once again, I am missing a number. I have 62, 188, and 134. Now let's look up here. 62, 188, and 134. The one piece that I'm missing are the people who didn't purchase concessions and saw no ads, which is this 116. That's what goes in the box out here because it doesn't belong to either circle. So let's interpret what we actually see there. The intersection of the 2 circles. Well, that's that 188 number, right? So that's 188 as far as the count. Using variables. If I want the intersection, that's an AND statement because they both have to happen. So that would be A and C. Or another way to write that would have been A with the little upside down N, or the upside down U, excuse me, and C. These are the people who saw an ad and purchased concessions. Okay. So now what about the ones that are inside circle A, but they're outside of circle C? That's going to be all the stuff in here. That's inside circle A, but outside circle C. So there's 62 of those. So if it's inside circle A, we want A, but not circle C. So we would say, and not C. Or you could do C with the little exponent of a C for the complement. So that's our notation for that one. So that would be people who saw an ad and didn't purchase concessions. So they did see the ad, but elected not to purchase any concessions. Okay, so what about the people who are inside circle A? Actually, it looks like it says the same thing. Okay, there's definitely a typo here. I don't know if it's on your page, but it's definitely on mine. So we're going to rewrite this because I don't know why it says it this way. This top one should be outside circle A because it literally says the same thing as the one above. And inside circle C. So outside of circle A, but inside of circle C is going to be here. It's inside circle C, but it's outside of circle A. So there's 134 of those. Inside circle C, so we want C, but we want not A. Yeah, that looks right. Okay. So that's going to be people who didn't see an ad but still purchased concessions. So didn't see an ad but did purchase concessions. That word just does not look at all like purchase. Okay, a little better. And then the last one is the people who didn't see an ad and didn't purchase any concessions or outside both circles. That's the little number down here. There were 116 of them. So we want something which is not A and not see. So that's people that didn't see an ad, didn't see an ad, and didn't purchase. I'm going to run out of room. We're going to say food. No concessions. Okay, so we've got all those different things written down as far as what could happen. So let's answer the last two questions. Write the event, did not see an ad, but purchase concessions in symbolic form. Okay, so the only difference is I want to actually write the fact that I'm doing the probability. So it's the probability of didn't see an ad, but purchase concessions. So we're talking about this category right here. So in symbolic form, it would be not a intersection or and purchase concessions. Symbolically, that's what that would look like. And then, of course, the probability of that is there was 134 of them out of the total number, which was 500 people. And again, if you end up doing the decimal, I think this one works out to be approximately 0.268 as a decimal, which is 26.8%. And you could just plug that in your calculator and figure that out. And then the last part says to explain why the probability of A or C is not equivalent to the probability of A plus C. Well, we did that same kind of thing in the previous problem. We could certainly show it by doing the additions and subtractions and all that kind of stuff. But again, it's mostly because of the intersection occurring twice. Because all the people in here would be accounted for with the A people, but it's also accounted for with the C people. So therefore, it would actually get counted twice, which is why the sum of those two individual things doesn't work out to be the OR statement. I'm going to erase those little things right there. So if we actually want to find that probability, we can do it of A or C. OR is a union statement. So we'll say it like that. Probability of A union with C. It's the probability of A plus the probability of C, which again, at this point, accounts for that middle section twice. So if I only want to count that middle section one time, I'm going to subtract one of the middle sections, which is the probability of A intersecting C. So basically, what this would have done if we did it using this thing right here, which is wrong, this part right here would have been accounted for twice. So in our case, we got the probability of A occurring, which if we go all the way back up is probability of A occurring is 250 out of 500, because there's 250 in this category for A out of the 500. Oops, 250 out of 500. The probability of C occurring, well, the probability of C is all of this stuff. There's 322 out of 500. There we go. And as you can see, if we just included those two things right there, we're way over 500 when we add them up. So we know that can't be right. We're going to subtract one of the intersections that would have occurred, which is going to be that one, let's see, 188 out of 500 minus 188 out of 500. And that should actually get us the actual probability. So let's see if we can figure out what that is. All right, fudge. doing a really quick, some quick math in the calculator there, that works out to be 384 out of 500. And that is the probability of the or statement, probability of A or C occurring. So one or the other. All right, that should do it for this lesson. Hopefully that's something you picked up on. But again, if it's something that went by a little too quickly, please go back, rewatch some of the videos, see if you can figure something out by slowing it down or watching it again.